Afternoon, good evening, everybody. My name is Vamsi Kemitiganti. I work as a general manager for financial services at Hortonworks. And in this role, I basically lead our engagement with clients across the spectrum of banking and financial services. And prior to coming to Red Hat, I spent about 8 years prior to coming to Hortonworks, I spent about 8 years at Red Hat as the chief architect of the banking vertical. So again, business and technology focused, and have been working with banks across the globe for quite a few years. So I bring that perspective into the massive amount of change and business value that Hadoop and Big Data and Hortonworks are driving in the banking industry. So before we go into our examination of the different areas of banking, and we talk about use cases and architectures, first and foremost, you might have heard a lot of news stories out in the media about the emergence of digital banking and the usage of advanced technology and mobility, as well as cloud computing to drive changes in banking. And this is a change we see across the different spectrum or different areas of the industry, be it capital markets, retail banking, wealth management, or even stock exchanges. So with that being said, there's a massive change going on in banking, and more banking operations are turning into digital organizations. And the idea with digital is to be able to engage your clients that are possibly younger and more comfortable with using multiple channels of banking. So these are folks that use their e-banking applications, their mobile applications, partner applications, et cetera, instead of just walking into the bank branch and performing their transactions. So from a business standpoint, obviously, the internet, cloud computing, and big data are driving a massive amount of change in banking. And this change is seen across all the different areas that make up your classical omni-channel modes of engagement with the bank. So there could be retail banks. This could also be our wealth managers. But also your payment systems with the advent of multiple modes of paying into the different organizations or businesses that you bank with. Banks are having to deal with multiple modes of payment. This ranges from your e-payments to your ATM card or your credit cards or whatever have you, down to blockchain as well in certain cases, and Bitcoin, et cetera. Having said all of this, there's also increased focus on compliance and regulation. So with the Basel III Accords, there's now more of a focus on making sure that banks are compliant with risk data aggregation across a whole range of business metrics, be it credit risk, market risk, liquidity risk, and as well as your compliance with anti-money laundering legislations. So these are some of the themes we'll examine today in this presentation. But suffice it to say that the common thread tying all of this in banking is data. And of all the industry verticals out there, banking produces the most amount of data. This is rich data that deals with customer transactions, core banking data, wire data, payment data, and position data, and risk data, et cetera, et cetera. But increasingly, more and more organizations in the banking world are moving to a data lake-based architecture. And this data lake stores cross-asset data in a cross-geo format and lets you run any kind of analytics on the data to be able to make your applications and your business more agile to your consumers. So when we work with our banking clients, we typically see that there is a virtuous cycle kind of mode of adoption, if you will. Most banks start with using big data and Hadoop to do data pooling and processing. So this is often done in conjunction with structured source of data, some of which I've mentioned a few seconds ago, or even with some of the newer social media, device data, telemetry data, point of sale data, et cetera, unstructured, semi-structured data. But once the data is collected and pooled into this enterprise data lake, banking organizations then start to glean value from it in terms of doing your business intelligence type applications. So in this kind of a mode, typically Hadoop works in conjunction with your Teradata's, your Netezza's, your Greenplums, your MPP databases, data warehouses, and then augments them to be able to provide visualization and to support multidimensional queries on the data. But as the banking organization starts to get more and more acquainted with Hadoop, more and more acquainted with all the different frameworks that are provided from a data processing and a data analytic capability, then the typical curve of adoption moves to being more of a predictive kind of model. And what you get with predictive analytics, machine learning, and data science are a way to basically able to not just look at what happened from a business standpoint, but also to be able to predict what might happen or what will happen based on the data streams that are flowing into your architecture, into your data center. So the range of applications for predictive vary from your cybersecurity to be able to identify anomalies or suspicious events, to fraud detection, where you are looking for out-of-band patterns of usage of certain financial products like credit cards, or even in the compliance space with understanding what a certain wire or a certain pattern of usage of a banking product could indicate from a know your customer or an anti-money laundering statute perspective. Again, this is a little simplistic in that this may not be the curve in every line of business in a bank, but this is a typical pattern I see unfolding across the hundreds of banking clients that we work with in a typical year. So before we go into the specific use cases themselves, let us consider the use of Hadoop or Hortonworks Hadoop at a top 5 international bank. This bank has been on the Hadoop journey since 2009. And as you can see, their usage curve started with your classical data pooling and processing with ETL augmentation. But over a period of time, they've been able to move Hadoop into more business-sensitive areas in capital markets. So they're essentially mining a lot of customer emails, call data records, in use cases like trade surveillance, as well as in use cases around single view of customer across multiple trading desks, equities, bonds, fixed income, commodities, et cetera, so that the bank can understand what customers are driving more business, as well as to be able to gauge their risk and exposure across either financial product lines or geographies or specific customers. But since that point, they've moved it on to areas like Customer 360 in wealth management, retail banking, as well as risk data aggregation management for credit risk, market risk, and fraud detection as well. Having said all of this, the banks that are early adopters that are moving Hadoop into more and more business-focused areas are able to save millions of dollars annually, and they're able to put this money to work in areas that can help them become a better business around digital transformation. So being able to tailor financial products in real time based on customer usage patterns across individual customer uses or across segments of customer populations is a big focus in banking. And to add to that, data products themselves, being able to take all the multiple sources of data that you have and then being able to apply predictive analytics to basically create newer mashups of the data or newer views of the data, or be able to take existing data assets and be able to create new products using them, and using these products as a service across a cloud or across the internet is becoming a large use case. And some banks have established programs for these data products, while others are taking baby steps towards them. But more and more, as you'll see, this is a way to kind of rank your customers on where they are from a maturity standpoint, and to be able to bring Hortonworks into all these discussions where we can help talk to your clients about these use cases, also help them articulate a vision of what's going on in banking, and act as trusted advisors to you when you help your clients implement these use cases on a real-world application. So in terms of global banking and Hortonworks, when we talk about banking as a whole, we look at banking in two different areas. The first one is the way banks are classified into customer-facing areas or external domains, which are typically our capital markets, investment banking, trading operations, hedge funds, et cetera. Retail banking, which is individual consumers, you or I walking into a bank branch or using our mobile applications or our e-banking application to bank with our financial provider, but also payment systems, the different modes in which payments could be made. This could be business to business or consumer to business, and then credit cards themselves. So within areas like credit cards, a huge need to understand your customers from the standpoint of their spending patterns, to tier them into different categories, but also to be able to detect fraud in real time as it happens. And then we'll talk about fraud detection in a second. But that's of itself a standalone vertical. It's about $150 billion a year in financial losses to the system through fraudulent usage of credit cards. The other areas where Hadoop has and Hortonworks has engaged with clients successfully is corporate banking and lending. This is where banks work with institutional clients and perform and provide corporate loans or provide other back-end services to their corporate clients. Being able to understand your customer, but also being able to understand the entities they bank with from the standpoint of risk, from the standpoint of AML, anti-money laundering, fraud detection, but also from the perspective of understanding your best customers and providing them with products that are responsive to their needs or their categories. The final area is private banking or wealth management. And this is around lending to high net worth investors and being able to gauge their risk appetites and being able to give them really tailored financial portfolios based on their life condition and based on their risk tolerance, instead of looking at them in a static kind of a way that older analytics products did so. Again, within these external areas shown on the left are all these internal focus areas. So every capital markets firm or retail bank or payment processor provides risk data aggregation and management functionality to internal audiences and to regulators. And the advantage of using Hadoop for these is instead of replicating data multiple times using the older EDW approach and running analytics that are proprietary on these data sets and not really being able to see the performance or the agility or the governance in the data from a quality standpoint, Hadoop, because of its focus on bringing all the data into one place, into a central data lake, or even multiple data ponds in larger organizations, offers you a way to run any kind of risk analytics type of processing on the data. And this is an area we spend a lot of time with our clients on. The other area is cybersecurity, which is somewhat an emerging area for Hadoop, but given the growing demands of mobility, bring your own device type computing, and also the usage of more and more cloud, there is a need now in banking to be able to capture, process, and refine data that's sent out from a variety of different services or devices or networks, but also being able to process the large streams of data and identify any anomalies in the data, and then understand what it means from a security event and a security analytics perspective. So we see a lot of applications towards data science in this area. And some of the recent acquisitions that we've made as an organization only indicate this with the Apache Metron project, which is now part of the Hortonworks data platform. The other use cases, which are fairly straightforward to understand, obviously fraud, we spoke about that. Digital banking, being able to provide banking from anywhere, but also being able to track consumers from an individual standpoint, and to be able to increase your uplift on every customer by about an average of 30% because of advanced visualization backed by predictive and real-time analytics is a big use case for big data. So having said all of this, let's dive right into some of these different use cases here. And then I'll maybe spend 2 minutes on each use case. If there's one area that you see that is of more interest than the other, we have exhaustive white papers that are focused towards the business as well as the technology in all these different areas that we can absolutely supply you with and also work with you with your customer on. So if you take a look at the digital journey in banking, one of the core areas around digital journey is data and analytics. So being able to understand what business goals you want to achieve, maybe that's increase customer uplift by a certain percentage, or maybe it's to convert 40% of existing auto loan customers into a credit card customer or into a mortgage customer. Because mortgages are some of the most stickiest products out there, and they're typically long-term products. Again, all of them talk about being able to do this deep analysis and wide analysis of real-time data and historical data to understand why customers are making the decisions they're making. And any framework that you create here has to be automated, deployable at scale. And that's kind of where big data and analytics is such a core part of digital banking. So if you look at this slide here, we spoke about the data lake a few minutes ago, but the idea is that a digital bank which has all these structured sources of data on the left and these unstructured sources of data in the middle, streaming data, call data records, customer clicks or customer sentiment data, any other unstructured data, all of this data is ingested into the central data lake. And the ingestion could happen using enterprise data flow management platform like Hortonworks Dataflow. And then once the data is in the lake, then using Yarn and basically allowing multiple types of processing to work on the data is a key use case. And then the data that's analyzed and understood can then be made available for consumption by a BI tool or by a machine learning algorithm, for instance. And the use cases around digital banking are 360 degree customer awareness. Also being able to understand what experience a certain customer is getting while navigating a financial product. And then being able to do surveillance on the data in a capital markets use case, or even to be able to do back office risk and compliance. And then while all of this is done, being able to create analytics as a service and to deliver them to your customers and to your partners from a business standpoint is key. We spoke about 360-degree view, and you'll see this across multiple areas that make up banking. So you'll see 360-degree view come up in retail banking with customer analytics and segmentation, but also from a risk and compliance standpoint, do I understand a single customer across all the entities that they're doing business with? Am I able to understand what their usage patterns connote in terms of compliance needs? So as an example, AML compliance or anti-money laundering compliance statutes are extremely critical for banks to comply with, because non-compliance can mean being fined by the regulators for billions of dollars on average, as well as a reputational risk that carries. So with a 360-degree view, we have customers that are doing global AML implementations that are able to track what a single customer profile looks like, be it an institutional customers, but also being able to track that profile across multiple geos and across potentially hundreds of entities that these customers are doing business with annually. And being able to understand and identify which of these social network links could indicate any kind of fraud or even upsell opportunities as time goes on. So within capital markets itself, a variety of use cases. So we spoke about being able to provide a single view of a customer across multiple trading desks, but also while we're doing that, being able to do trade and market surveillance becomes a big use case. As capital markets firms have to maintain internal repositories of all trade data, position data, and are expected to be able to feed this into back-end surveillance systems for analytical calculations that are either statistical in nature or time series in nature, so that they can understand if there's any integrity compromises or any violations of insider trading statutes that could be going on. And then finally, being able to use big data as part of the trade lifecycle development. So a lot of algorithmic trading is based on automated trade strategies. Being able to take an algorithm and backtest it across years and years of data potentially, and being able to do this in a few hours as compared to the typical weeks that it took in the past is a big use of big data. It's a big use of Hadoop and big data techniques as we see it. And then finally, within the capital market spectrum, stock exchanges are obviously, a household name, given that every household beyond a certain income level has some exposure to the stock market. You'll see that more and more stock exchanges have turned into data product oriented organizations. So unlike in the past, where stock exchanges were run using listing fees, currently in the industry, given the huge amount of data that they're running across multiple areas, multiple asset classes, be they equities or mortgage-backed securities or derivatives or whatever have you, they're handling a lot of data. But now they're finding out that with the raw data they have, they can leverage Hadoop to basically run a whole range of analytics on the data, and then expose this data to their consumers, be it hedge funds, be it brokerage houses, or be it trading desks in investment banks, to be able to perform deep analytics on the data without having to onboard the data themselves and sell this as a product to their clients. So having said all of this, wealth and asset management is another large fertile area for Hadoop. Again, wealth management firms span the spectrum in terms of the services that they provide. So you could have retirement planning or other institutional services, estate planning services, investment advisory, or even full service investment banking that's provided in wealth management. But again, within the global wealth management umbrella itself, use cases vary from being able to serve your customer better by leveraging big data techniques, by offering a seamless experience with Customer 360, being able to help a customer look at all their accounts in one central place, instead of logging on to multiple systems, and for one for retirement, one for credit cards, one for retail banking, and the other for their stock portfolios, etc. Being able to provide one unified place so that they could do their financial workflow, but then being able to use that to by the advisor to basically track a customer journey and then to do investment research and understand what portion of their customer pool are targets for the promotion of a new financial product. So being able to perform market basket analysis, similarity analysis, and clustering of customers in one place, I think is a huge use case where customers are finding, clients in wealth management are finding value from Hortonworks Hadoop. At the back end, with the ability of Hadoop to basically create technology-led innovations, areas like robo-advisors are starting to be more and more in vogue. And the idea here is that Hadoop is used as a platform to run predictive data modeling algorithms. And the robo-advisor itself is a collection of algorithms that can assist a tech-savvy customer with portfolio optimization and with financial life planning services. And then from a back and mid-office standpoint, risk data aggregation, anti-money laundering compliance, and reporting as well is starting to be a big use case for Hadoop. And this spans all these different areas as well, not just wealth management, but within wealth management, being able to provide regulatory reports, internal reports, and data that's inside Hadoop is becoming a very topical use case. This picture here talks about how a typical customer segmentation process would work. And again, this will be part of this part of the wealth management collateral that we could provide you with if there's interest in looking more deeper into this area. Now, having discussed some of the front office type use cases, in the mid and back financial office, the first use case for Hadoop tends to be risk and regulatory data reporting. We have a number of global banking institutions that are running Hadoop-based data lakes as a chosen platform for a range of risk data aggregation reporting applications. So this could be the Basel III umbrella set of applications, or BCBS 239, which is a manual for risk data aggregation reporting, but also areas like Dodd-Frank and Volcker Rule, etc. But what Hadoop can provide you with is a central platform that can ingest book of record transaction data from a range of different systems, and then being able to help you standardize the data ingestion and the processing and the calculation of the data from a unified analytics standpoint. So again, a slide here that talks about the architecture of a typical risk data aggregation project. So on the left, you have the golden source of data and the feeds of data that are feeding into the data lake that's in the green rectangle in the center. Data lands inside Hadoop, and the data is then standardized using Apache Atlas typically. The data is then processed with analytics that are applied on the data, and then depending on the type of reports the system on the right expects, you could use the different tool sets inside Hadoop to be able to expose data via SQL query, or to be able to even load data into an Oracle at the back end, so that a Hyperion or whatever have you can perform analytics on the data. And we work with a range of partners here in banking to be able to ensure that Hortonworks data platform is certified with your SAS, your Talent, your MicroStrategy, your Cognos, or whatever tools are in vogue at most of the banks. The other area around predictive analytics and data science. So all of these areas that we've discussed before in consumer banking, wealth management, payment processing, financial trading are all susceptible to a data science-based approach. And data science can really help not just ensure that the appropriate models are run on the data and the models are self-learning, but it's been shown in areas like credit card fraud, cut fraud down across tens of thousands of points and transactions by a huge margin of about 40% typically. So chances are any type of fraud application you have, even AML or InfoSec, Hadoop and big data are starting to augment existing approaches in these areas. Cybersecurity is a new one for big data, but it's starting to pick up massive business steam. And I wager that in banking, in about a year, it'll probably be one of the, it's now one of the top 5 cases, and it'll probably be top 2 or 3. And the reason for this is obviously as banking becomes more digital, there's a need to capture data, process data from not just the top of the iceberg, as it's shown here, as existing systems do, but also to be able to onboard other unstructured data from inside or from devices or networks that are in your organization or external to your customers' banking organization. And once the data is all captured, being able to correlate all these data sets using an unsupervised method of learning on the data that can provide you with an understanding of what are certain new security events based on historical patterns of the data, but also any other insights and detection and identification of a business risk based on the data. So again, cybersecurity by itself is a very interesting subject, and it's pretty vast in banking. But some of the specific business type use cases are around credit card fraud detection, shared surveillance in capital markets, and other compromises of applications that are running on servers based on usage patterns. So a wide combination of external threats, network traffic, and user activity, and even policy violations in your organization. So I discussed AML, but the one thing around AML is we're seeing a more higher degree of sophistication among criminals that are looking to launder funds. And AML programs are now moving to a consolidation with fraud, as well as with risk of projects. But the core use case remains that a lot of real-time analytics have to be performed on data across geographies and products and accounts. And to be able to provide your existing expert or rule-based system with an augmentation in terms of this is a certain pattern of usage of an application, what is the risk score? And if the risk score is more than, say, 0.4, I want to go in and to be able to do deeper analysis on the data using data science. That's kind of where the industry is going to. And within the ML projects itself, being able to ingest data in batch or real time or at high speed, and then being able to correlate that data with historical data and to be able to perform any kind of analytics on the data is a key use case. I discussed fraud monitoring and detection. Using Hadoop, using Hortonworks Hadoop, our banking clients are able to put a data ingestion strategy that spans multiple channels, as shown here: web, kiosk, call center, in-store, and mobile. But not only being able to ingest that, but being able to run models on the data and to be able to process the data at scale to look for sub-second response times on certain use cases that pertain to credit card fraud, are emerging to be are coming out to be massive areas of cost takeout for our clients. So being able to do more with less, but also being able to detect fraud violations in milliseconds that had been a huge problem as they're dealing with massive volumes of card usage are some areas where Hadoop's adding a lot of value. So maybe one last point here is around data quality itself. One of the areas we spend a lot of time on is to make sure that the data is not just ingested and processed, but also to be able to perform governance on the data in banking organizations. So around chain of custody of the data, being able to track every data element from ingestion to reporting, and to be able to understand who touched the data at what point, and is that an auditable event, and can I have a historical lineage across all of this data are all emerging and important use cases as more and more capabilities in banking move to a Hadoop-based architecture. So having said all of that, the data governance initiative for Hadoop was the DGI, as we call it, was started with the help of a major financial institution, and their usage of Hadoop is currently exploding. And based on the requirements that they've given us and the joint development we had done with them, the DGI initiative is now a reality. So when you put Hadoop and Hadoop-based components to your business use cases that we've discussed a few minutes ago, you can rest assured that Hadoop can interoperate from a metadata standpoint and from a governance standpoint with other investments in your data management architecture. So again, the important thing to convey here is our approach to working with our customers and partners is to essentially work closely and to bring all the insights that we're seeing from our global banking base into our partner organization. So this is around areas that we just discussed, but also being able to take some of the business practices and the learnings that we have gleaned or found out from working with our global partners and with our global clients can really help you accelerate your implementations at customer sites. But also, we also offer models like CoDev or more joint engineering type activity that can help your clients address some of the more cutting edge use cases and drive innovation down into their platform. Again, with that being said, across all these areas, we can definitely provide you with white papers, architectures, as well as help you with your customer meetings as applicable. With that in mind, thank you for the opportunity to present to you all today, and looking forward to speaking to you all one-on-one in the days to come. Thank you so much.